Uh, so my name is Aditya Kulkarni. This is my presentation for the short story of 255 data mining. So I have selected a paper called Zero is Not Hero Yet, which is benchmarking of the zero-shot performance of LLMs for financial tasks. So let's get started. So let's start with the introduction. What we're going to do is we're going to delve into the performance of LLMs in zero-shot scenarios, especially in the context of finance, where labeled data is often scarce. So yeah. So next is how ChatGPT has impacted the finance domain. Since its introduction, it has shown promise in interpreting complex financial communication, analyzing and predicting trends in AI. But a survey indicates that ChatGPT outperforms fine-tuned models only on 20 to 5% of the tasks. So yeah. And then even though zero-shot ChatGPT fails to outperform the fine-tuned models, it still provides impressive performance across the tasks without having access to any level data. So that's something. And the gap between fine-tuned models and ChatGPT is larger, where the data set is not publicly available yet. I mean, that would be a given since the model does not have any reference for creating labels. Um, the the performance of the fully open source LLM for all financial tasks is significantly lower as compared to ChatGPT. Um, uh, and in certain scenarios, even if the user is willing to accept the performance difference between the zero-shot LLM and fine-tuned models, the amount of time required varies greatly. I mean, ChatGPT takes a lot of time to label unseen samples, and it's almost 100,000 times greater while using generative LLMs. Next, we have dataset and tasks. So we analyze several tasks, including sentiment analysis, numerical claim detection, and named entity recognition. Let's see what they are one by one. In numerical claim detection, there are two terms which are in claim and out claim. In claim basically are the statements that contain specific measurable financial claims, and which are not factual statements. They actually contribute to future financial transactions. Outclaims refers to sentences that contain factual information only, and they are generally there from the past. Then there's named entity recognition. It plays a crucial role in financial NLP. It enables extraction and categorization of key financial entities, such as company names, persons, locations, etc. Facilitate this enables us to recognize, various organizations or individuals that are involved in any certain financial task. For example, someone we use credit cards and online payment apps to pay for anything. That way, these transactions are getting marked for categories of the transaction, and the merchant and the organization that the payment was sent to, etc. So NER plays a crucial role in identifying all those entities. Uh, NER also facilitates important entities involved in financial news and reports. So basically, statements and financial reports, account statements, etc. NER is very crucial for information extraction and enhancing the decision-making process in financial NLP. Um, there were the paper mentions four experiments which were conducted in total. The four experiments are fine-tuning models, fine-tunings, zero shot, and the second one was zero shot with generative LLMs, which had four sub-experiments. One was FOMC communication, sentiment analysis, numerical claim detection, and named entity recognition. So the results after this experimentation are, let's discuss those. So with fine-tuning, Robert A. Bayes and Robert A. Large, they have similar performances and they outperform zero-shot LLMs because they have labeled data, and basically they get trained on that, and they obviously perform better than uh, generative LLM. Although ChatGPT does not have an impressive performance, it follows the instruction 100% of the time, and 100% of the time, and while the other models such as Dolly and H2O fail to follow the instructions. So uh, fail to follow the instructions 6.05% and 42.14% of the time, respectively. Uh, Also, uh, the sentiment, the results of the sentiment analysis are similar, but there are but there are a few key differences, such as the H2O model doesn't follow the instruction at all. It failed 100% to follow the given instructions, but ChatGPT scored impressively with a F1 score of 0.9 for the sentiment analysis, which is not far from the fine-tuned Robert A model. Then for numerical claim detection, the gap between ChatGPT model and fine-tuned model is larger here compared to the sentiment analysis task, while the gap between Dolly and ChatGPT is smaller. The exact reason for this gap is uncertain, but one possibility for this could be the contamination of the data, considering that sentiment analysis dataset is publicly available while the claim dataset is not publicly available. So exploring the potential contamination issues is an explanation for this discrepancy. It would be an intriguing avenue for the future research. Other results also follow this same trend. Then next is named entity recognition. Um, in this it is similar. It is similar to previous results. It follows the same consistent pattern, but the NER prompt proves to be more challenging as compared to other tasks, leading to both open source models to struggle in adhering to given instructions. Also, decoding labels from the prompt output is relatively more difficult in token classification compared to sequence classification tasks, which results in a larger number of samples with missing labels. So yeah. There's one thing that I missed for the experiments, specifically for these four. So for this FOMC sentiment analysis and numerical claim detection and named entity recognition, there were specific prompts were given to the generative LLM. So for FOMC communication, the prompt mentioned something like classify the following sentences from FOMC into hawkish, dovish, or neutral class. So the label hawkish means if it is corresponding to tightening of the monetary policy. Dovish means if it is corresponding to easing of the monetary policy, and neutral if the stance is neutral. Then for sentiment analysis, the prompt was to classify the sentences into negative, positive, or neutral. So the label negative meant it is corresponding to a negative sentiment, positive meant positive if it's a positive sentiment, or neutral if the sentiment is neutral. Then for numerical claim detection, the prompt was to classify the sentences into in claim or out claim. As I mentioned earlier, if the label will be in claim if it consists of a claim and not just factual past or present information, and out claim if it has just factual past or present information. Then lastly, for named entity recognition, the prompt was basically below a sentence is tokenized, and each line contains a word token from the sentence. So identify a person, location, and organization from them and label them. If the entity is multi-token, use a postfix underscore b for the first label and underscore I for the remaining token labels for the particular entity. And for the named entity recognition, GPT was also told to not combine words by itself and to use a colon to separate token and label. So these were the specific prompts used for all of these experiments, and we have already discussed these results. So finally, in conclusion, as observed through the experimentation results, while fine-tuned PLMs generally outperform zero-shot GPT, GPT still demonstrates a huge performance across various tasks without the need for label data. It follows the instructions to the word 100% of the time in all of the experiments. Then there was a notable performance gap which was identified between fine-tuned PLMs and ChatGPT, particularly in the case where there was no labeled data. But this could be potentially due to lack of contamination issues. And lastly, despite the potential performance gaps between zero-shot generative LLMs and fine-tuned models, the time required to label a single sample using GPT is significantly higher by a factor of 1,000. So this was my presentation for the short story assignment of data mining 255. Thank you.